So anyway, welcome everyone. I just realised I had myself muted, so that must have been fun watching my lips move. And I've got a guest in the green room who's laughing away because they can hear us and hear me and realise that I was not quite there. But anyway, let's get into it. Let's not chit-chat around too much. So Toolbox Tech Talk today is all about earth fault alarms and the requirements in our PV array, our battery standard, and our grid inverter standard. All of those standards tie in with the requirements for an earth fault alarm. So I'm going to do a little brief explainer with my usual overhead drawings, and then I'm going to bring in a guest and we're going to talk about some actual products. So let's dive into it. So first up, the question really that comes up is, why do we need an earth fault alarm at all? What's the problem? So the problem is that we've got a system here using a maximum power point tracker. Now, a maximum power point tracker, and I should probably zoom in a little bit more. Here we go, to make that a bit clearer and move that over there. Maximum power point tracker is a DC-DC conversion device and also something that operates generally either a PV array or other devices with variable impedance at the optimum power point. And so, hence the word maximum power point tracker, MPPT. Now, the symbol for it here is DC-DC conversion. And this is a non-separated MPPT. Now, that's really important in terms of earth fault alarm requirements. A non-separated MPPT is one that has no galvanic separation. Now, it may be that one or other of the poles are connected directly through, so you might have the negative conductor is passed through uninterrupted, or you might have the positive conductor that's passed through uninterrupted. And when it's operating, it's switching electronics that's doing the conversion. It's not actually an isolation, a galvanic isolation. So the problem that we get with this arrangement is that, let's take this scenario here. We've got a battery, let's call it a 48 volt battery. So it's less than 60 volts. And you'll see why that's important in a minute. So let's say we've got a 48 volt battery here. Notionally, that's, in the old terminology, extra low voltage, but as you'll see when we talk about inverter standards and battery standards, the battery standard now deems anything over 60 volts for more than 0.2 of a second under any operating or fault condition to be a hazardous voltage level. So hazardous voltage now for battery systems is dropped right down to 60 volts. So we might think we're below 60 volts, so it's got a lower protection requirement. But because we don't have that galvanic separation between the array, and in this case the array is operating at LV, it's operating above 120 volts. And so at over 120 volts, we've now got the possibility that if there was an earth fault here, the voltage measured on the battery positive to earth or the PV array positive to earth is the same because there is no galvanic separation. So suddenly the battery port has been raised to an LV level. And that's a hazardous situation. So in the case of a non-separated MPPT, we need to have an earth fault alarm because that potential can exist. So that's a non-separated MPPT. And you might be asking me, what's the norm? Well, actually, the norm is non-separated MPPT. So they're pretty common. Let's look at the next slide. And here we've got a separated MPPT. Now, not so common. In fact, my guest might be able to tell me, I'm just flagging this one, which ones do have galvanic separation that are on the market in Australia. But if it does have galvanic separation, I've shown it like it's got a isolating transformer inside. That means the electrons on the PV array side can't cross over to the electrons on the battery side. And therefore, the battery's voltage determines the voltage at V2 and the PV array voltage at V1. So in this case, if we have an earth fault on this side, we're not going to see a high voltage or the PV array voltage appear on the battery port. We're only going to see the maximum voltage of the battery. But on the PV array side, we still have an LV PV array. And so an earth fault on this side, if it's over 120 volts, we're required to have a galvanic earth fault detection on the PV array side. So in this case, we've got to detect that earth fault here. And so that's V1 could be up to 120 volts or above, whereas V2 is going to be at the battery voltage. So one last drawing before we start talking about some actual product is just to introduce this concept of what's known as decisive voltage classifications. Now, decisive voltage classifications comes from the IEC. The IEC 62109 standard for part 1 is for MPPTs and charge controllers, and part 2 for inverters. Introduce this concept of different classifications at different DC voltages, and it's a hazard risk assessment. So you could say A is the lowest risk and C is the highest risk. What we've done with our standards in Australia, we've deemed for battery systems that are greater than 60 volts, therefore 60 volts upwards are deemed to be equivalent to an LV installation. Therefore, as far as our licensing and mechanical protection and insulation and a whole bunch of other things, we deem this to be effectively an LV system on the battery port. So that means that now a 61 volt battery being over 60 volts is an equivalent to an LV installation and requires an earth fault alarm on the battery port. It requires double insulation on the cables. It requires a mechanical protection as per an LV cable. So that's been a big change. So that's just a little explainer about DVCs. Now I'll just come back to the main screen. So look, I've got a return guest today, and this I'll just bring him in. Okay, Peter, g'day.
Hey Glenn, how are you?
I'm good, thanks, Peter. So Peter's from AERL, and we had a little chat some weeks or months ago now about the history of AERL, didn't we?
We did. We had a really good conversation on one of your earlier tech toolboxes.
Yeah, we did indeed. Now, I'm managing a few buttons here, so there might be a little bit of clipping off of my voice as I try and mute myself whenever Peter speaks. We discovered we were in our little pre-tech that there was a little bit of an audio loop going back to him, so I have to press a mute button. But so just tell us a bit about our AERL before we launch into talking about the products.
Sure. AERL's a renewable energy power electronics company based here in Brisbane, Australia. And we've been designing power electronics for remote applications now for over 35 years. Our claim to fame, I guess, is the fact that we developed the original MPPT. It's the first commercialized MPPT back in 1984, which is in line with the sort of the founding of the company. And to this day, we still make some pretty tonka tough MPPTs, amongst other things.
Cool. So, look, I've got a really more important question based on our last live event. Was where is your cat?
Far away. He will not be interrupting this particular live stream.
Yeah, some cats have a predilection for walking in front of cameras across keyboards and cutting off your connection.
Yes, yes they do. Or breaking things.
So, look, without further ado, let's talk a bit about the SRX and the EarthGuard product. I've got a couple here right next to me, and I'm going to do my very first, I think it's almost my first, unboxing. So I'll just bring you on full screen, and you can talk about it, and I'll just get it ready to unbox. So here we go.
Sure.
Tell us about the SRX, please.
Okay, so the SRX is a 300 volt open circuit capable MPPT designed and manufactured here in Australia. This is the latest generation AERL charge controller. It's got all the bells and whistles you'd expect from a high-end premium quality MPPT. We released it in late 2019, first generation, and we've been making since, and they're proving to be quite the good little unit.
Okay, well, look, it's so big. This is the box. I'm just going to take it out of the box and then put it on the table where you can see it with the overhead camera a bit better. But it's not super heavy. I'm just sitting in a chair a bit awkwardly. So, look, it comes with beautiful packaging. There's something for the cat to play with. And the all-important installation instructions, make sure you read that. I think there's even an acronym for people who call you up who haven't read the manual. Is that right?
I can neither confirm nor deny this.
And we've got a little slip of paper in here. It's probably a thank you. Oh, there we go. Look, a warranty. Well, a 3-year warranty from the original purchase. And you are the original purchaser, and register your warranty online within 60 days. You get 5 years warranty. So that's pretty cool. 5 years warranty if you register online, which is pretty damned easy to do. So let me just bring the Beastie out of the box. There it is. And there we go. So that is one beautiful looking piece of equipment.
Yes, and you may notice that it is, if you were to put it up against sort of some of the comparable MPPTs on the market, that it's quite a bit larger. So I feel like that's probably worth addressing, actually, while you've got it there and you're holding it. There's 2 reasons for that, primarily. One, it has a higher input voltage, so we have to account for the extra heat load, because the higher the input voltage, or the greater the differential between the PV and battery, really, the more thermal losses you'll have. And the second thing is we like our electronics to run very cool. So you can sort of cut costs and skimp on heatsink sizes, but we tend to like, because we design our electronics to last a very long time, and they go into very mission critical remote applications, we can't afford to have anything that's going to sort of make them wear out or degrade. Or if it's avoidable, we like to avoid it. So that's why that we went for such a large heatsink on that thing, and it just runs so damn cool, which is great for longevity.
Well, it's going to put it down because it's also a little bit heavy.
Yes, it is.
Yeah, so there's the Beastie, and it's got a beautiful screen, which of course you can't see. It's a color screen, and it's a touch screen. Now I've got a bit of a funny story which Peter knows all about. When he first sent me one of these, I said, "How do I program this thing? There's no buttons anywhere."
Yes. I think you eventually worked it out, though. Or I hope you did.
Is this that you are sort of ahead of the curve, really, using a touchscreen on an MPPT?
Oh, look, it made sense. No one likes the little finicky buttons on the front of the machine to try and program them. And back in the days when we first came up with the concept, smartphone adoption just wasn't at the same level as it was now. So you really couldn't, having a Bluetooth commissioning method, which wasn't viable at the time. But yes, smartphone adoption's come a long way in a very short period of time. So that's now an alternative, but we still like the screen because, customers can, well, actually the end user, it's great for commissioning, makes it a very quick process. But the end user can just quickly check the state of their batteries and that sort of thing without having to navigate through finicky menus or anything like that, which is generally we have really good feedback on.
Yeah, cool. All right. Well, speaking of cool, which is the Cool Max, we've got one more product coming up here, which is kind of the main reason for today, the Earth Guard. Now, let me just grab that. Another lovely box, somewhat lighter and smaller. So, and yes, and it also has something for the cat to play with.
Mm-hmm. That's mandatory on all our shipments.
And we've got the installation and operation manual. We've got a warranty document, which no doubt Peter knows all about, but I'll just check it here because I haven't had a look at it. And it's the same conditions. So it's a 3-year warranty for the original purchaser, but an additional 2 years, so a total of 5 years warranty if you register it online within 60 days. So, yeah, 5-year warranty on both products, basically, if you register them. So that's great. Thanks, Peter.
No worries. I like to keep our warranties consistent across our product range. So there's just you don't have to wonder. Makes things simple.
All right, so let's delve into the box now. Wonder what that is. I'll find out in a second. And here we go. Here's the main event, the Earth Guard. So this is it, the Earth Guard. And I think if I hold it up to the camera, you can probably see it. Camera seems to like to focus on me, so I'll bring it back a bit. So there you go.
Yes, it looks remarkably similar to the SRX. You might have noticed.
I'll just put them together. Actually, now what's this box?
Well, that would be all the fun bits and pieces that come with the Earth Guard. So you'll find in there that there's an industrial grade USB-C power supply, as well as the cable glands for actually installing the device.
So we've got a USB-C industrial grade power supply. That's going straight onto my Raspberry Pi, thanks. And
it's a 15-watt charger, actually, originally spec'd for the Raspberry Pi. So there you go.
Yeah, the Pi 4 is pretty power hungry. And we've got some compression glands here for cable entry points.
Yep, that's it. I feel like I should actually clarify too. The reason that we went for a USB supply on this particular device is because it's doing DC earth fault detection. The power supply for the device needs to be isolated from the system that it's testing, which is if by powering off AC, you can actually, you can disconnect the PV array and basically keep the AC inverter on to actually power the device for your troubleshooting and all that sort of stuff. So we figured it was kind of actually had a multi-purpose benefit there. And it's just quite easy and straightforward to use.
Okay, that makes total sense. So I understand why it's got a USB as opposed to an AC supply. Yeah, so it's pretty simple to connect by the look of it. You've just got DC positive, DC negative, and earth. And is that going to a battery or a PV array, or does it matter?
So they're installed on the battery. It's for either 48 volt or 120 volt battery systems. And yeah, it just gets wired straight onto the battery bus.
So it looks pretty much the same as the unit. Let me just line them up on my overhead here.
Yes, there's a pretty good reason for that, actually.
Yeah, what's the reason?
Okay, so when you install an Earth Guard with one of our controllers, and if, for example, if you install, it requires that the Coolmax is installed. But if it is installed with the rear entry ports, you can remove the top plate of the Earth Guard and the cable glands out of the base of the SRX, and then there's a recess on the Earth Guard, and then they just nicely slot into each other. So it looks like one long unit when it's actually mounted on the wall.
I gotcha. So yeah, I can see if I take this top plate off here with the 4 Phillips head screws, then this whole unit slides straight over the top and becomes effectively one unit.
That's right, yes.
Very nice, very clean. That's great. Okay, well, let me just move these aside. Oh, those heat sinks are sharp. I should have had my gloves on, not my bling on. But yeah, they're quite sharp, aren't they?
Be careful with those.
Sharp edges dissipate heat better, though, so that's a good thing.
They do, but there's a fine line between too sharp. Maybe that's something we need to improve on.
Okay, so I've got a few questions for you. Now, first up is there's a requirement in the standard. Now, I've got some of the clauses in front of me for all the clause buffs here. The requirement in 5033 was the first that introduced the earth fault alarm requirement, and it was for LV arrays, and that meant anything over 120 volts DC under any operating conditions. So even the coldest conditions, you're required to measure what the maximum open circuit voltage was. So we introduced it with 5033, but more interestingly, we then introduced it with the new battery standard, 5139, with this strange clause which said you shall install an earth fault alarm unless no product is available on the market. So have you really cornered the market then?
Look, yes, in a sense. I mean, it's been a few years since that original standard release now, and no one had really bothered to actually bring something to market that was suitable for PV and battery applications. And then it became an even more of a requirement with 5139 that we figured, okay, we need to actually do this and bring an earth fault product to the market, because otherwise it's going to eventually impact the sales of our MPPTs because it is a requirement, and it's just you start to get into liabilities and that sort of thing. It just gets a bit questionable. And we kind of had a pretty good idea how to do it, so we thought, well, let's build an earth fault alarm and make it happen.
Actually, a little correction on my behalf. Sorry, you were right. It was 5033 that introduced the requirement initially with the exemption if no product was available. But as soon as a product is available, you were required to do it. But that was the 120 volt kind of point was where we deemed it a requirement, which with MPPTs generally is about the 3-panel mark. You hit going over 120 volts these days. So it didn't take long for it to trigger on most installations. But then with the battery standard, we lowered that hazardous voltage to 60 volts and also required it to detect earth fault alarm, earth fault on the battery port side. Now, is that any different? Is it more difficult? Or is it the same test?
The way we designed the EarthGuard, as I said earlier, it's actually mounted on the battery bus. So because of the fact that it's required on non-galvanically isolated products that often do have a common positive or a common negative connection through, we're actually able to, we realize that from a central point in the system that we can actually tackle both the battery ground fault and the PV ground fault detection at once, because effectively it's all just one big circuit. So that's what we did, and we figured we could just kill two birds with one stone and design a product that was actually, that monitors the entire system from that central location, which is the major benefit of the EarthGuard over any other sort of, because there's a couple of earth fault or leakage detectors on the market at the moment, and they're really designed for things like rail applications and a bunch of other industry-specific applications. So nothing was really designed for PV. So it really, and honestly, if you were to use something like that on your system, you generally end up requiring one per array. And with the EarthGuard, you just have one box that gets wired onto the battery bus, and you can have as many MPPTs in the system as you want. So it brought the cost of DC systems or DC coupled systems back to earth, because without the EarthGuard, it was going to be a very expensive proposition once it was a requirement.
Great. Okay, so I was just fiddling with the controls here to see if there's any questions. Feel free, everyone, I've now got the ability to see both YouTube, Facebook, LinkedIn, and Twitter comments coming through. So feel free to throw some comments at me, or even just thumbs up, say you're enjoying the live stream, and subscribe if you're on one of those channels where you subscribe. That would be great. But let's going back to this product. You're welcome to mention products, Peter, but there are a couple of products on the market that do have ground fault detection. And we had a little chat before the show, and you said that they don't really comply with Australian standards. Can you explain what they are and why they don't comply?
Yeah, absolutely. So you may have seen that a couple of the more common regulators and MPPTs on the market, like the the 300 volt Outback, for example, as well as the the Morningstar MPPT. They also both have ground fault detection built in, but this is not specifically designed for the Australian market, where we install floating PV here. It's not functionally earthed. So the Morningstar and the Outback units, they do have ground fault detection. Actually, the Strata does too. They have ground fault detection built in, but it's only for positive or negatively functionally earthed systems. So if the positive or negative in the system is actually directly connected to earth. If everything's floating, that the ground fault detection doesn't work, because that's not what it's designed for. The US market is it's predominantly functional earthing over there, so that's what they spec their devices out for, being US products.
All right, I'll just do a little bit of translation there. So in the US, they refer to ground instead of earth. So you'll see ground fault detection used in US products. We talk about earth fault detection. And as Peter pointed out, the methodology used in the US assumes that you have a functionally earthed system because it's a requirement of the National Electrical Code, whereas in Australia that's a very unusual design. You are allowed to do it, but there's a whole bunch of requirements too. You actually need what's called a ground fault interrupter if you have a functionally earthed system in Australia. So that's a different kettle of fish, generally done with a fuse or something similar. I can just see some questions coming in. So before I babble on a bit too much, I'm going to just throw up a question. So I'll bring that on screen. Here we go. So this one's from Jeff Bragg. He's a friend of mine. He's also the president of SCIA and in New South Wales. I think you still are, Jeff, and also a board member of the Smart Energy Council. Now, Jeff's asking, do you need an earth guard on a battery port side of an SP Pro? So I think I can sort of answer this one, Jeff. So it depends on the voltage of the battery. So if the battery is above 60 volts for more than 0.2 of a second, under any operating conditions, yes, you do need an earth fault detection on that system if it's not galvanically isolated from the PV array. So it depends on what source of PV charging you have connected to that battery. If it's AC charging from a galvanically isolated SP Pro, then you don't have that potential for the earth fault because it's galvanically isolated. But if it's charged through an MPPT, then you do. Now, do you confer, Peter?
Yes. So pretty much a 48 volt SP Pro that's AC coupled. The PV inverters generally take care of the earth fault detection on the PV side, and because of the fact the SP Pro is galvanically isolated, it's not required on the battery side. But Selectronic make a 120 volt inverter as well, and it is required on that unit because of the fact it is above 60 volts.
Great. Okay, we've got another question here. This one's from Quentin. Quentin says, I presume he's referring to the EarthGuard product, is it compatible with other brand MPPTs to retrofit to an existing system?
Yes, absolutely. While it is designed to integrate with the Coolax, it's a neat little package. We're pretty agnostic about what you can use it with. So it's a standalone product, and you can use it on basically any other MPPT out there that requires it.
Great. So it actually solves a problem for other manufacturers.
Yes.
Have you tested it with other manufacturers?
Yes, we have. We've done pretty extensive testing at this point. There's not a whole lot of products left out there that we haven't actually given it a whirl with. So we've got pretty good compatibility across the range.
And we've got a slightly oblique question here from Bradley. G'day, Bradley. You're one of my solid Sunday fans. You're often there watching, I notice. So Bradley is asking battery voltage range. What battery voltage range does the EarthGuard and the SRX work with?
Okay, so it's designed specifically at the moment for 48 volt and 120 volt. And up to 300 volts on the system voltage, maximum system voltage. So in the event of an earth fault, the device can handle up to 300 volts. So that's kind of spec'd around our existing hardware with our chargers. But we may look at doing a higher voltage earth guard at some point down the future if that's where the market goes. But for now, it's 48 and 120 volt.
Great. Thanks for that question, Bradley. More broadly, I've got some other questions here, which is more about just using DC-coupled solutions. Why would a solar designer or installer choose to DC-couple a solar array to a battery as opposed to using an AC-coupled solution?
Okay, there's a couple of reasons there. There is quite significant restrictions, for one, around inverter sizing, grid-connected inverter sizing. So if you're doing a grid-connected battery backup system, you're going to run out of charging capacity very quickly, but those same sizing restrictions don't apply to DC coupled. So you can get around sort of grid restrictions just by DC coupling the battery storage. Now, in terms of on a more technical level, there is definitely significant benefits to DC coupling because of the fact that you're doing DC to DC battery charging as opposed to AC to DC battery charging, which is generally not the cleanest form of DC once it's been converted back from AC to DC. So it tends to have still some of that AC ripple in it, which can cause heating in batteries. And effectively, if you're charging them very hard with an inverter charger, you can fairly drastically shorten the lifespan of the battery system by AC coupling exclusively. Now, this was it's quite a significant problem with lead acid chemistries, but the court's still a little bit out in terms of what effect that AC coupled ripple charging has on lithium battery chemistries. But we're doing that research at the moment in our laboratory in Brisbane, so we'll have some better ideas on that subject shortly.
All right. Okay. Oh, so you're doing R&D on Ripple. I wasn't aware of that. That's really interesting. So I've got another question. This one's from Simon. Let's just bring it up on screen. So Simon Parker asks, what is the cost of the Earth Guard in Australia? Are you happy to talk about pricing?
Yeah, sure. Why not? It's pretty standard across the range. So they are $525 plus GST. That's trade pricing, of course, which I figure probably applies to most people watching the stream. But again, there is a discount as well we do subsidize the cost when you purchase them together with a Coolmax. So that's another option if you're interested in using our chargers. That brings down the overall system cost just a little bit. But yeah, they're $525 plus GST on their own.
Great. Okay. So everyone, feel free to throw some more questions into the chat. This is working well for me. I can actually see the questions quite clearly because the previous Toolbox Text Talk, I had to jump around different screens to try and read the questions. But I'll give a little plug to the software I'm using, by the way. It's a company called Ecamm Live. This is their new beta version with what they call Interview, where I can do what I'm doing now, which is bring guests in. In fact, I can bring up to 4 guests on screen at the same time. It's even got this cool function called the green room, where I can just chuck Peter into the green room. He can listen and watch, but we can't hear him. He can't speak. But it's kind of a nice way of doing a live event. So just going back to my list of questions here. We've covered on the different ways that other manufacturers do earth fault detection, which is not compatible with our Australian standards. What's new about the SRX? It's had a long history and it's changed its form factor significantly since the earlier models that I've seen. What's changed with the SRX?
Okay, so the SRX, we're always, we can't help ourselves. We like to keep improving things. But the previous SRX that you would have had there at the Smart Energy Lab would have been a Generation 1. It was a very early one. I think it was probably serial number 6 or around that. But this one is a Generation 2 SRX. So from the outside, it looks a little bit, it looks relatively similar, albeit it's a more polished product overall. But inside, it's significantly different. You'll see that when you go to install it. But there's been a whole bunch of hardware improvements and upgrades. It runs cooler. It's slightly more efficient. It's just, it's an all-round better product than the Generation 1 SRX.
Speaking of efficiency, do you know what the efficiency of the unit is?
Yes, I think the MV1 is about 98.6%. But that's because we've got 300 volt input going down to 48, so we lose a little bit there. But the 120 volt one is up over 99%.
Wow, 99% efficient. That's just insane. I guess there's not much space to go, is there? You're not going to get to 101%.
No, you're definitely not. That probably defies the laws of physics.
All right, we've got another question here from an anonymous Facebook user. So just bring that one on. Is AC ripple reduced if you have both AC and DC arrays on the same battery?
It's heavily dependent on charging capacity. So if it's charging on the AC system, it's going to have AC ripple in there. The only way to reduce your AC ripple in the system is predominantly charge with DC and size your daytime loads for the AC, which is personally what I think is the best way to do it, because then you're charging the batteries with really smooth, clean DC for nighttime loads, and the AC is being fed straight to the house for AC loads, which makes a lot of sense, in my opinion. Oh, you muted.
Ooh, nearly did it. A combination of both AC and DC coupling is actually a winning combination. I mean, I often think of it for off-grid as your protection against your AC coupling not working whenever you have a black event. For those who are not familiar with this terminology, if you've got a fully AC coupled off-grid system, so you've got a solar inverter that outputs AC, you've got a battery inverter that it couples to on the AC bus, and if the battery inverter goes down, like you've discharged the battery overnight and it shuts down, even when the sun comes up in the morning, no charge is going to come in, because that battery inverter has to form a grid to which the solar inverter synchronizes with. And if it's turned off, it won't synchronize with anything and you won't charge your battery. And that's why DC coupling is really the most reliable way, independent way of ensuring a battery gets charged from a renewable source. It's just going to do it when the sun comes up. And it may be really a small system even, but it's going to protect that battery from staying discharged and possible call-outs. How do you feel about that description?
That's pretty damn accurate. Yeah, that's one of the other great benefits of DC coupling.
Okay, I think I've run through my questions. I've covered the cat. That's good. Yeah, and we've looked at we've looked at the SRX and EarthGuard, and we've differentiated between ground fault detection requirements in our Australian standards versus the National Electrical Code of the US, which has different requirements. I should point out that you can functionally earth systems in Australia as well, but it's very uncommon to do this. There's no real advantage to it. You could say it's all disadvantages. It's kind of inherently less safe, but there is some applications where functional earthing, not for power generation, but for other purposes, makes some sense. And I think you make a product that specifically does this, don't you, Peter?
Yeah, we do. So we actually make something that is effectively a big earth fault, but it's an intentional earth fault for protecting metallic structures. So we're pumping DC current through a metallic structure down into an anode bed to protect it from corrosion. Yeah, it was a bit of a challenge to work out how the hell we do earth fault detection on that system, because technically it actually does fall under the PV standard if it's a PV powered cathodic protection system. So that was a fun little experiment we had to do.
But you with a functionally earth system, you have the additional requirement of a ground fault interrupter, so not just detection. That's
correct. The circuit has to be broken because with a floating earth, you have 2 points of failure. And the EarthGuard will pick that up. So it'll pick up when the first point of failure is degrading. It'll trigger the alarm before there's actually any serious risk or current flowing to Earth. Whereas with a functionally Earth system, you only have 1 point of failure. You've already got one pole that's directly Earth, so you only need the other one to break down, and you've got a short to Earth. Which is why it needs to be interrupted.
Yeah, gotcha. Would it work on a vehicle? I had a friend who had a Land Rover, and it was always corroding because it's aluminium body, and so he went and bought some expensive thing at one of those aftermarket shops that supposedly did cathodic protection and injected some current into it. I don't know where he got it from. Could he put a PV panel on the roof of his four-wheel drive and do cathodic protection?
I don't know if it would work on something that's got rubber tires. That's going to be one I'll have to look into. I don't have an answer for you off the top of my head.
Maybe it's a new market, is cathodic protection on those aluminium cars that might be coming out one day.
Yes, or any of the four-wheel drives that are already existing.
The fun fact, he actually lived at Coolum, so where you are right now. So salt, mist,
There you
air.
go. Yes,
All right. Well, look, we've been having a nice chat here, and I think we've covered all the material I wanted to, but I've got a couple of plugs. So I might just say farewell to Peter and just wind up the show with just a few end announcements. So thanks very much, Peter.
Absolutely, Glenn. Thanks for having me. It's great to be here.
Okay. Well, I'll send you back to the green room and enjoy the rest of your afternoon. Cool. So, yeah, that was Peter Watkinson from AERL. I've known Peter for a long time, and I love the products, and thanks very much for sending them to me here at the Smart Energy Lab. For those who are not familiar with what I do, I run training courses like this online, live, one-on-one or one-on-several, almost every other week. So this week coming up, I'm doing a 3-day course just for electrical inspectors. Well, it's not just for electrical inspectors. It's actually for anyone interested in the very detailed aspects of our renewable energy standards. Specifically 5033 for PV arrays, 5139 for battery systems, and 4777 Part 1 for inverter systems connected to the utility grid. So we'll be doing that on Tuesday, Wednesday, Thursday, starting at 7:30 each morning for 4 hours. So you can enroll in my courses online, solarquip.com. Just go to solarquip.com and you can find those courses. Then a couple of weeks later, I'm doing a 5-day solar and battery design course. It's similarly 4 hours a day. These are all delivered via Zoom, by the way. So it's a classroom environment. You're all on screen together. Generally, it's just 10 to 12 people, and we will be discussing and sharing information. I'll be explaining stuff, but also in those courses, I give homework. So for the design course, you get to design and build a theoretical model for a solar and battery storage system to meet a certain load energy requirement. So it's all based on our standard for standalone power systems 4509 Part 2 for design and Part 1 for installation, but we also cover hybrid systems as well. So we look at the requirements for designing a hybrid system and some of the compliance issues for that. So that's like a 5-day course, but it's only every morning from I think it's 8:30 till 12:30. So it's half-day courses with a bit of homework as well. Anyway, so that's my plug for my training courses, and thanks everyone for coming and watching this live. I'll be back next Sunday for another Toolbox Tech Talk at 2 p.m. So until then, see you, mate. Bye.